Welcome to G Fun Facts Online. When you hear the word nuclear, what's the first thing that pops into your head? For most people, it's a giant power plant with massive cooling towers. And you're not wrong, but that's only a tiny piece of a much bigger, much more fascinating puzzle. Today, we're diving deep into the world of nuclear facilities, and I promise you, they are far more than just power stations. They are the hidden engines of innovation, shaping our future in ways you might never have imagined. Let's start with the basics. Around the world, there are about 440 nuclear power reactors churning out roughly 9% of the planet's electricity. That's a huge deal for providing stable, low-carbon energy that helps fight climate change. But here's where it gets really interesting. Beyond making our lights turn on, there are over 220 research reactors in more than 50 countries. These aren't built for power. They're built to produce something called neutrons. These tiny particles are scientific superstars. In medicine, they help create radioisotopes that are used in tens of millions of procedures every year to diagnose and fight diseases like cancer. In agriculture, they're used to develop stronger crops that can resist pests and to sterilize food, making it last longer and stay safe. They even help industries perform complex analyses and could one day provide the intense heat needed for making glass or cement. And for all the space fans out there, nuclear technology is literally out of this world. Since 1961, radioisotope power sources have been the reliable heartbeat of iconic missions to the Moon, to Mars, and even to the edge of our solar system with the Voyager probes. So how do these engineering marvels actually work? Inside a nuclear power plant, the reactor core controls a nuclear chain reaction, which generates an incredible amount of heat. This heat boils water, creating high-pressure steam. The steam then spins giant turbines, which are connected to generators, and voila, you have electricity. The most common designs today are the pressurized water reactor and the boiling water reactor. But the industry is on the verge of a revolution. Engineers are developing Generation 4 reactors, like molten salt reactors, which promise to be safer, more efficient, and produce less waste. Another game changer is the Small Modular Reactor, or SMR. Think of them as compact, factory-built nuclear power sources that can be set up in remote areas, or places that don't need a massive plant, offering clean, reliable power on a smaller scale. And this field isn't stuck in the past. It's sprinting into the digital age. Artificial intelligence and machine learning are being used to optimize how fuel is used and predict when equipment might fail. Engineers are creating digital twins, perfect virtual copies of entire facilities, to run simulations and train staff in a completely safe environment. And yes, they're even deploying robots like the famous Spot the Dog robot to go into hazardous areas for inspections and maintenance, keeping human workers safe. Now, let's talk about the elephant in the room: safety. Safety and security are the absolute top priorities in the nuclear industry. The core philosophy is called defense in depth. Imagine it like a medieval castle with multiple walls, a moat, and guards at every gate. Nuclear facilities have multiple independent and redundant layers of protection. This includes strong physical security, massive containment buildings designed to withstand extreme events, and multiple backup systems for all critical functions like cooling. And in our connected world, robust cybersecurity is essential to protect these plants from digital threats. All of this is watched over by strict national and international regulators like the International Atomic Energy Agency. Of course, none of this incredible technology works without brilliant people. The industry relies on a highly skilled workforce, and there's a huge push to attract a new generation of engineers and technicians through university programs and international collaboration. Projects like the massive ITER fusion reactor in France show what's possible when countries work together, sharing knowledge to solve huge challenges like managing nuclear waste. So what's next? The future of nuclear engineering is incredibly bright. We're looking at using nuclear energy for large-scale, clean hydrogen production, powering advanced manufacturing, and even making human missions to Mars a reality. Nuclear facilities are not just infrastructure, they are powerful engines of discovery. As we push for a cleaner, more secure, and more prosperous world, this critical technology will be more important than ever. Thanks for tuning in to G Fun Facts Online.